Right. In this next example, we're going to look at a little bit of our relationship between our cardinality between sets. So we're going to look at our cardinality comparing set A, set B, our union, and our intersection. And we have a little equation here. So if you noticed in your skill check for this section that there were some questions that we're asking you to go through and just solve some basic equations. And that was put in there on purpose because of what we're looking at in these. All right. So for our equation that we're going to be dealing with, for any finite sets A and B, everything we've been dealing with in the section have been finite sets because we've had a limited number of items in there. The number of elements that are in A union B is going to be the number of elements that are in set A plus the number of elements that are in set B minus the number of elements that are in the intersection. And the idea is here, we want to, if we're finding all of the elements that's in either or both, we just want to make sure that we don't double count people that are in that both category in the middle. So that's why we have that subtraction. All right. So as we set up these problems and we go through them, I'm going to use this equation. We're going to interpret this little story problem that we have, kind of label some things as we did in chapter 10, kind of make a list of everything that we know, and then go from there. So the results of a survey of visitors at the Grand Canyon showed that 25 people speak Spanish, 14 people speak French, and 4 speak both Spanish and French. How many speak Spanish or French? So first we're going to define our sets. So we are going to let A be the people that speak Spanish and let B be the people that speak French. All right, so now we need to list out what we know. Right, so the number of elements in set A, our cardinality of A. Right, the number of people that speak Spanish is 25. Right, our cardinality of B, the number of people that speak French, is 14. The number of people that speak both, right, that's A intersect B, is 4. So what we're looking for is the number of A union B, right? The number of people that speak either Spanish or French. Right? So we're going to use this equation that's up top here. So I'm going to start by writing that out. The number of elements or cardinality of A union B equals n parentheses A plus n parentheses B minus n parentheses A intersect B. All right, so this is what we're looking for. Right, the number of elements in A union B, the number of people that speak Spanish or French, the number of people that speak Spanish, right, n parentheses A is 25. Right. Then we're going to have plus n parentheses B, the number of people that speak French, which is 14, minus n parentheses A intersect B, the number of people that speak both, so we have minus 4. Right. And if we go through and we just do this quick calculation, 25 plus 14 gives us 39. 39 minus 4 gives us 35 people. Right, so 35 people speak Spanish or French. Right. So this is one way that we can use this equation that we see. Right, example 8 is going to be similar. However, we're going to be looking for and solving for a different variable, but we're going to set this up the same way. We're going to start by listing, figuring out what A and B are going to represent, list out all of our different variables, and the numbers that are associated with those, and then go through and solve the problem. Okay, so of the homes listed for sale with RE/MAX, 39 have either a 2-car garage or a fireplace, 31 have a fireplace and 18 have both a fireplace and a 2-car garage. How many of these homes has a 2-car garage? So we are going to, it doesn't really matter again which you pick for which as long as we stay consistent. So we're going to let A be the number of homes that have a 2-car garage, and we'll let B be the number of homes that have a fireplace. Those are the two different things that we are talking about in this problem. All right, our cardinality of A, the number of homes that have a 2-car garage, well, that's what we're looking for, right? That's our missing variable. Right, our cardinality of B, the number of homes that have a fireplace, is 31. 31 have a fireplace. Right. The number of homes that have both. Right, so A intersect B, that's going to be 18. And the number of homes that have either a 2-car garage or fireplace is 39. Okay. So we have all of our different variables there. And then I'm just going to copy down this equation again from up here. So N A union B equals N of A plus N of B minus N of A intersect B. All right, so now we're going to start plugging in the information that we know. Just moved it up a little bit to give us a little more room. All right, so N of A union B is 39. So 39 equals the number of elements in set A, the number of houses that have a garage. Well, we don't know, so that's our variable. You can call it X if you want to. I'm just going to leave it like that. Plus N of B, so plus 31, minus N of A intersect B, minus 18. Right, so now we do have a little equation to solve. Right, first thing I'm going to do is I'm going to combine these two terms on this side. So I have 39 equals N of A plus, if we subtract 31 minus 18 gives us a positive 13. Now to solve our equation, we want to cancel out this 13. So we're going to subtract 13 from both sides. And if we subtract 39 minus 13 is going to give us our answer. I suppose that guy should have been green if we're staying consistent with our color in here. Right. So the number of homes that have a garage, 39 minus 13 is going to give us 26. So we're going to say 26 homes have a 2-car garage. All right. So looking at these particular problems, again, we're kind of connecting some of the different ideas that we're looking at, and we're also solving just kind of some basic mathematical equations, talking about the relationship between our cardinalities of these different sets.